Today we are going to talk about histogram and how we can use it to get data back. We are going to use Santley's solar eclipse image, which was downloaded from his Google Drive page. You see that the disk here is pitch black, but is it pitch black? Let's find it out. We see here the histogram, and you see that there is a tiny gap at the left edge of the histogram. We are going to use the info tab in Photoshop. Now we don't have the information yet. Here I scrub up with the pointer, so I'll take the right pointer. Takes me a while until I see what is wrong. So okay, let's take the select tool, and here we see that the black has a value, so it has 3, 4, 5, 6, sometimes 0, but it has a value. What does this mean? It means that the image contains data, so there is an image behind the black disk, which we can bring back out using photographical image enhancement techniques, standard techniques used in Photoshop. So you can see that the histogram has a value, so we're going to bring it back using the levels. So I'm using a level enhancement layer. Using enhancement layers means you can deselect them and you go back to the original state of the image, so you don't alter the original image. So you can see that there is data behind the blacks, so the image is not clipped in the blacks. That was what it means, having an histogram with a value here. So using the levels we are in fact stretching the image. Stretching is a normal astrophotographical image enhancement technique. So you can see after stretching that the very low values are increased by the image stretching technique. So a side effect of the stretching is that you also increase the noise. And now we are making a copy of the original image, and we apply a median filter to reduce the noise. We do it step by step, 1 pixel at a time. So you see, just moving the layers gives you a different result, but the original image isn't touched by this process. So we repeat the noise reduction technique I'm using for almost all my imaging techniques and image processing runs. It's fairly standard. This was a misclick. And let's do it again. Let's use more noise median pixels, but here you can see that it's overdone, so we are going to go a step back and do the median filter. Let's try it one more time with 1 pixel then. And just deselecting the visual settings of the layer, you can see the difference. Now we apply a contrast curve. What we are trying to do is to get the contrast of the blacks and highlights good. So for the message on my phone. And to decrease the blue in the image, we adjust a curve on the blue layer just for minor aesthetical viewing pleasure. Voilà. Now we have the moon image I'm going to zoom out, and this makes the lunar features more easily visible. After this I'm opening a carte du ciel. It's a planetarium software program. It's freeware. It's very good. I highly recommend it. Let's close some tabs in Photoshop so we can watch here. So we are going to the August 21st. Daytime settings. 15 hours. Okay. Apply. Okay. Change observatory to some place in the United States. It's not actually a place where the lunar and solar eclipse was visible, but I needed the moon image. I can also use a proper place where there was a solar eclipse, where you can see the trajectory of the moon going over the sun. And voila, here you have it. You have the features of the moon, how it was during the time of the eclipse, more or less. The rectangular box is a overlay in the software for an autoguider if you use that for your astrophotographical usage. And as you can see, the features in the image are present. And why was I able to recreate them? It was because the blacks weren't clipped. You had some information left which was visible in the histogram, and here you can see the histogram after the stretch where we brought back the blacks in the image. Voila, that was it.